Hello viewers, today we are going to see how the bistable multivibrator is functioning. This is one of the important topics in multivibrators. In future videos, we will discuss about monostable multivibrator and astable multivibrator. All these three topics are equally important and you can expect one of these three topics for your final semester examination. Before going into the topic, let me introduce the most important keywords of the multivibrators. They are state, stable state and quasi-stable state. State is actually voltage levels. They are high level and low level. High level means plus VCC, which is 12 volt for transistorized electronic circuits, and low level is 0 volt. In either way, it can be called as logic 1 and logic 0 in terms of digital electronics. The second keyword is stable state. Multivibrator will stay in this state indefinitely until the trigger pulse is applied to it. The third one is quasi-stable state. This is actually temporary stable state or unstable state. The circuit will stay at this state for only short interval of time. Now let me give a short introduction about multivibrators and then we'll move on to the working of bistable multivibrator. Multivibrators are electronic circuits which are used to generate non-sinusoidal waveforms such as square waveform, rectangular waveform, sawtooth waveform and so on. Multivibrator is also called as non-sinusoidal waveform generator since it is generating non-sinusoidal waveforms. It is a two-stage amplifier operating in two states as I mentioned earlier. Since multivibrators are operating in two states, they are used to implement two-state systems such as flip-flops, timers, oscillators. Depending upon the number of stable states present in the multivibrator and the working of the multivibrators, will classify the multivibrators into three categories: bistable multivibrator, monostable multivibrator and astable multivibrators. Let's see one by one. The first one is bistable multivibrator. From the name itself, we can understand that it has got two stable states. This circuit can stay indefinitely in either of two stable states. This circuit requires external trigger pulse to change its state from one stable state to another stable state. This circuit is also called as flip-flop circuit. The second one is monostable multivibrator. It has one stable state and one quasi-stable state. This circuit requires external trigger pulse for changing its state from stable state to quasi-stable state. But it does not require any external trigger pulse to change its state from quasi-stable state to stable state. Other names of monostable multivibrators are one-shot multivibrator and univibrator. The last one is astable multivibrator. Astable means no stable. It has two quasi-stable states. This circuit does not require any external trigger pulse to change its state from one quasi-stable state to another quasi-stable state. Hence it is called free-running multivibrator. This circuit is also called as square wave generator since it is generating square waveform at its output without the help of external trigger pulse. To understand the operation of the bistable multivibrator better, we will see the switching properties of the transistor. Now let us find what are the output voltage and output current when one transistor is at off state as well as in on state. First we'll see when a transistor is at off state. When the input voltage applied between base and emitter junction of the transistor is less than the cut-in voltage, which is 0.7 volt for silicon and 0.3 volt for germanium, then the transistor goes to off state, which means the collector and emitter terminals of the transistor are getting open circuited. So no current will be flowing through the collector terminal, which is equal to 0. So the voltage across the collector to emitter terminal will be equal to VCC. Since the collector and emitter terminals are getting open circuited, the entire supply voltage will be applied across the output terminal. Let me summarize this. When a transistor is at off state, the collector and emitter terminals are open circuited. The collector current IC equal to 0 and collector to emitter voltage is equal to VCC, which is equal to output voltage. Next we'll see the output voltage and output current when a transistor is at on state. When the input voltage applied between the base and the emitter junction of the transistor is greater than the cut-in voltage, then the transistor will go to on state, which means the collector and the emitter terminals of the transistor are getting shorted here. So more current will be flowing through the collector terminal, which is equal to IC saturation. The voltage across the collector to emitter terminal will be equal to 0, since the voltage across the short circuited terminal is 0. Let me summarize this. When a transistor is at on state, the collector and the emitter are short circuited. The collector current IC equal to IC saturation. Then the collector to emitter voltage VC equal to 0, which is equal to VCE saturation practically. Now we'll see the working of bistable multivibrator. This is the circuit diagram. Here we can see the transistors Q1 and Q2 are cross coupled. The collector of the transistor 1 is coupled to the base of the transistor 2 through the resistor R1. And collector of the transistor 2 is coupled to the base of the transistor 1 through the resistor R2. The resistor RL1 is the load resistor or collector resistor of transistor Q1. The resistor RL2 is the load resistor or collector resistor of the transistor 2. These two resistors RL2 and RL1 are identical. The resistor R1 and R2 are identical. The transistors Q1 and Q2 are NPN transistors. Both are identical. The minus VBB voltage is given to the base of the transistor 1 and base of the transistor 2 through the resistors R3 and R4. These two resistors are also identical. This minus VBB will help the bistable multivibrator circuit to stay in its stable state. When the power supply is switched on, both the transistors Q1 and Q2 are trying to conduct. Although the components present in both the stages are identical, one of the transistor will conduct more than the other due to the difference in the doping levels of the transistors 1 and 2. Now let us assume that transistor 1 is conducting more than the transistor 2 for our discussion. So the transistor 1 is going to on state, which means the collector and the emitter terminals of the transistor 1 is getting shorted. So more current will be flowing through the collector terminal, which is equal to IC saturation. The voltage across the collector to emitter terminal will be VCE saturation, that is almost equal to 0, which is coupled to the base of the transistor 2 here. This voltage is very much lesser than the cut-in voltage of this transistor 2. So this will turn the transistor 2 to off state. Once it is off, the collector and emitter terminals are getting open circuited. So no current will be flowing through this collector terminal, which is equal to 0. The voltage across the collector to emitter terminal will be VCC as per our earlier discussion. This is the one stable state of the bistable multivibrator, that is Q1 on and Q2 off. The circuit will stay at this state until the external trigger pulses such as set or reset pulse is given to the base of the transistor 1 or transistor 2. Now let us assume the reset pulse is given to the base of the transistor 2, which means we are going to give a positive going trigger pulse to the base of the transistor 2, which is very much greater than the cut-in voltage of this transistor 2 as well as the minus VBB applied to the base of the transistor 2. So the transistor 2 will switch from off to on state, which means collector and the emitter terminal of the transistor 2 is getting shorted now. So more current will be flowing through the collector terminal, which is IC saturation. The voltage across the collector to emitter terminal will be VCE saturation. That voltage is almost equal to 0, is coupled to the base of the transistor 1 here. This voltage is not at all sufficient to keep the transistor 1 in on state itself. So this will bring the transistor 1 from on to off state. Once it is off, the collector and the emitter terminals of the transistor 1 is getting open circuited. So no current will be flowing through the collector terminal. So that is IC equal to 0. The voltage across the collector to emitter terminal will be VCC. This is the second stable state of the bistable multivibrator, that is Q1 off and Q2 on. The circuit will stay at this stable state until the external set trigger pulse is given to the base of the transistor 1. Once the set trigger pulse is given to the base of the transistor 1, the transistor 1 will switch from off to on state. Due to the regenerative operation, the transistor 2 will switch from on to off state. Hence we can conclude the bistable multivibrator will stay either at plus VCC or VCE saturation until the external trigger pulses are given to it. The transition from one stable state to another stable state will not be done quickly because of the resistive coupling between the output of the one transistor to the input of the other transistor. So we have to connect the capacitor C2 in shunt with resistor R2 and the capacitor C1 in shunt with resistor R1. These two capacitors are increasing the speed of the transition. Since these capacitors are increasing the speed of the transition, they are called as speed up capacitor. These two capacitors are also called as commutative capacitor or transpose capacitor. Because of these capacitors, the transition from one stable state to another stable state will be done very quickly. The bistable multivibrator circuit is also called as flip-flop circuit because it functions as like a flip-flop. You know what is flip-flop? Flip-flop is a memory element which stores one bit of binary information at a time. Likewise, bistable multivibrator also stores either plus VCC, that is logic 1, or VCE saturation, that is logic 0 at its output for indefinite time period. Now we'll see how to draw the output waveforms of the bistable multivibrator. The first graph refers to the output of the transistor 1, which is VC1. The second waveform refers to the output of the transistor 2, which is VC2. The third one is reset triggered pulse. The fourth one is set triggered pulse. Now I have divided the entire waveform into some 6 time slots. For the first time slot, I have assumed Q1 is at on state, Q2 is at off state. During the second time slot, I have taken Q1 is at off state and Q2 is at on state. The third time slot and fifth time slot are similar to the first one. The fourth time slot and sixth time slots are similar to the second slot. Now we'll see how to draw the output of the transistor 1. For drawing the VC1, we should see the states of the transistor 1. So during the first time slot, the transistor 1 is at on state. When the transistor 1 is at on state, what is the output voltage? Which is VCE saturation. So the output of the transistor 1 will stay at VCE saturation. During the second time slot, the transistor 1 is at off state. So what is the output voltage when transistor 1 is at off state, which is VCC? So the output of the transistor 1 will switch from VCE sat to VCC. And during the third time slot, the output of the transistor 1 is VCE sat. So the circuit will switch from VCC to VCE sat and it repeats. And we'll see how to draw the output of the transistor 2, which is VC2. We'll see the first time slot. During the first time slot, what is the state of the transistor 2? The transistor 2 is at off state. When the transistor 2 is at off state, what is the output voltage VC2? Which is VCC. So the circuit will stay at VCC during the first time slot. Then for the second time slot, the transistor 2 is at on state. When the transistor 2 is at on state, the output voltage of the transistor 2 is VCE saturation. So the output will switch from VCC to VCE saturation. And for the third time slot, the output of the transistor 2 is VCC. So the circuit will switch from VCE saturation to VCC and it repeats. With the help of the output of the bistable multivibrator, which is the VC2 waveform, will understand the reset and set pulses. The output of the bistable multivibrator will stay at logic 1 during the first stable state as per our discussion. So the circuit will stay at this logic 1 level until the external trigger pulse, which is reset pulse, given to the transistor 2. Once it is given to the transistor 2, the circuit will switch from logic 1 to logic 0. The circuit will maintain at this logic 0 level until the set trigger pulse is given to the transistor 1. Once the set trigger pulse is given to the transistor 1, the circuit will switch from logic 0 to logic 1. The circuit will maintain at this logic 1 level until the reset trigger pulse is given to the transistor 2. Once it is given, the circuit will switch from logic 1 to logic 0, and this repeats. Next, we'll see the applications of the bistable multivibrator. Bistable multivibrators are used to perform digital operations such as counting and storing. As bistable multivibrator is functioning as flip-flop, it can be used as memory element in shift registers, counters, and also can be widely used in computer memory. Multivibrators are used to generate and process the pulse type waveforms. Thank you.